Today, this is the second class for binomial distribution. This is the second class for binomial theorem, not distribution. In the previous class, there was discussion up to the seed question. See the number 1, 2, 3, 4 and 6 part 1 to the ending problem here. See this problem here. Question number 6. Find the independent term of x. Find the independent term of x in the expansion. Number 1. X minus 2 by x square whole to the power 15. We always follow the question number 5. See the previous video for the binomial theorem. Follow the same as question number 6. If we find always the independent term of x, we let us assume the independent term of x is lie on the r plus 1 term, okay? Let us assume r plus 1 term contain the free from x. So that's why tr plus 1 is equal to 15 cr. And now this is x to the power 15 minus r and minus 2 by x square whole to the power r. And this is followed by the general term, okay? And now it is done by the powers index power of x to the power 15 minus r and minus 2 to the power r, and here is x to the power 2r, and they are simplified by x to the power 15 minus 3r. As this is the term free from x, so the degree of x is here 0. Free from x means that the term where x do not belongs to the other variable like x to the power 2, 3, okay? So free from x means x to the power 0. Always there are x to the power 0. So we compare with x to the power 0. Therefore power is compare 15 minus 3 r equal to 0, then r equal to 5. Therefore the free from x is here. Put the value of r here. That is 5. 15c 5 minus 2 to the power r. That is 5r. This is the free from x here. Okay. And see here. We follow always and find the value of r here. And clearly, this is an integer. If this integer be negative or fraction, therefore that term do not belong to there. If we find the coefficient of like here a to the power minus 11, if we get the value of r here is fraction or negative, so there does not belongs to the coefficient of a to the power minus 11. Okay, so r would be always positive integer. Okay. And now the question part number 2. Part number 2, that is 1 minus x square and x plus 1 by x to the power 7 independent term of x of the expansion. Okay. Okay, independent term of x here. So first of all we expand this formula 1 minus twice x plus x square and x plus 1 by x whole to the power 7. Okay, and multiply this 1 by x to the power 7 minus twice x or x plus 1 by x to the power 7 and x square whole to the power 7 here. So see, this whole thing are free from x. We need to find the solution by the find the general term, okay? And now see here, we have to find first of all the r term, tr plus 1 term of the expansion. This is here 7 cr for x plus 1 by x whole to the power 7, okay? 7cr and x to the power 7 minus r and 1 by x to the power r, okay? 7cr, x to the power 7 minus r and minus r, okay? Therefore the free from x, therefore the free from x of the expansion of the expansion of the given expansion. Okay, that is equal to, see here, that is the coefficient here is 1, and now free from x, then 7 minus 2 are equal to 0. So that is 2 are equal to 7. So 7 by 2. See, this is the fraction of, that is 7 by 2. This is the fraction number. So for this within the bracket, there do not belongs to the free from x. Okay, therefore we can assume here it is 0. Again, for the next term, see, this is 2 into x here. So we always like that, x to the power 7 minus 2 here, we need to find the value of free from x within this bracket, as this is degree 1. So within the bracket, if we expand, so there are the negative term, that is x to the power minus, negative means degree to be negative, that is x to the power minus 1. So compare with x to the power minus 1. Okay, so 7 minus 2r is equal to minus 1. So 2r is equal to 8 here. So r is equal to 4. So therefore coefficient here is 7c4. Okay, again there is x square. There is x square. So compare with same as x to the power 7 minus 2r, that is x to the power minus 2r. Okay, as we see x to the power minus 2r, this is plus 2. If we multiply both the term, then we got 0. Then we see that the free from x there. Okay, that's why we always take the negative degree. Okay, negative indices. Okay, so now see 7 minus 2r, that is minus 2. So 2r equal to 9. So there is a fraction of r. So in the third term, that does not belongs to the free from x there. Okay, so free from x is 2 into 7c4 is your answer. Okay, and now question number 7. See the question number 7. This is a very important question. We have to find the middle term of our expansion. So if we find the middle term of the expansion, we always follow the number of term. Okay, this is the only discussion about the positive index for the expansion. So this is not an infinite series. So middle term means there are finite number of term of there. Okay, see here, if a plus x whole to the power 10. See, if the power be 10, so total number of term is 11. So first of all, we find the number of term there. Okay, see here, if this is the number of term 1, 2, 3, 4, 5, visualize this 1, 2, 3, 4, 5. This is the 5 term. So see that this is the middle term. So how could we find this term? As this is the number of term is small, that is 5. So see the middle term is third. Mathematically it is denoted by, as this is the odd number. If we get the number of term be odd, so we always 1 be added to the odd number. That is 6. 6 by 2, that is third. This is the procedure. If we have a number of term be 10. Let's see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See here, this is the 2 middle term. Okay, this is the 2 middle term. So if the number of term be even, we always that number divided by 2. We get fifth term and also next term. So if the total number of term be even, we always divide by 2. If the total number of term be 100, for example, then 100 by 2, that is 50 and also 51. See here like that, this is the number of term 10 divided by 2, this is 5 and we got again 6. Fifth and 6 is the 2 middle term for the number of term be even. If the number of term be odd, then we got a single middle term. Okay, for example, this is a 5 number of term, so middle term is third. How could we find this? So if the order number of term be odd, we always add the add the number 1 with the odd number, that is 5 plus 1 by 2, that is 6 by 2, that is third. Okay. So here the question, the expansion is x plus 1 by 2x to the power 2n. So total number of term is 2n plus 1. Okay, this is 2n plus 1, which is odd. Okay, so the middle term is equal to, according to theory, we said that if the order number be odd, we always add 1 and divided by 2, that is th term. Okay, this is the middle term. And now find Tn plus 1. Expansion is this, so we have always, that is 2nc, this is n, and x to the power 2n minus n, and now that is x, that is 1 by twice x to the power n. Okay, 2ncn, x to the power n, 2 to the power n, and x to the power n. Okay, that is 2ncn by 2 to the power n. This is the answer. But see, we have to show this formation to be simplified. Okay, formation. So now we expand this, that is factorial 2n, factorial n into 1 by 2n, 2 to the power n. Now 2n can be written as 2n minus 1, 2n minus 2, dot, like 5, 4, 3, 2, 1. Any integer factorial can be expanded up to 1, okay, like that. This is factorial n, and 2 to the power n. And now even and odd are separated, like that 1, 3, 5, which we have to show. So odd number are separate, even and odd are separated by this, that is 2n minus 2, 4, 2, 1, factorial n and 2 to the power n. Okay, see here, if the factorial 2n, it means total number of factor of the expansion. If we write that 1, 2, 3, 4, dot to 2n, so there are the 2n factor. Half of the number be even and half of the number be odd. Okay, so this is the odd number, total number of term here is n, and this is also an even, total number of term is n. Okay, from this factor, each and every factor, we take a factor common, that is 2. So there the total number of term be n, so we have taken 2, that is the number of 2's is n, so their product be 2 to the power n. So let's say again, we have taken a common 2 from each and every factor, so their product is 2 to the power n. And again write there n minus 1, n minus 2, dot 2, 1. Okay, again write this from 1, 3, 5, dot, that is 2n minus 1. Okay, and remaining all of factorial n, and 2 to the power n. Okay, and this is 2 to the power n, factorial n, 1, 3, 5, and dot 2, 2n minus 1. Okay, divided by factorial n, and 2 to the power n. Okay, these are cancelled. Okay, and that is equal to 1, 3, 5, dot 2n minus 1 whole divided by factorial n. This is your answer. Okay, this is your answer. See the solution again clearly. Now, see the question number 8 here. Question number 8. Question number 8. If the coefficient of the expansion of this, that is the expansion, first of all written here, 1 plus x to the power 10, and find t suffix 2r plus 1. This is 2r plus 1, okay. That is 10cr, that is 2r, and there are a to the power, means 1 to the power, something means 1, and x to the power, that is 2r. Again t suffix 4r plus 5, that can be written as 4r plus 4 plus 1, and that is equal to expansion, this is 10, okay. 10c 4r plus 4 and x to the power 4r plus 4 there, okay. By the given condition, the coefficient of these and these are same, okay. By given condition, 10c 2r is equal to 10c 4r plus this. Then find the value of r. Then find the value of r, okay. So see here, if we get this relation, so number 1 point, write this 10 equal to 10, okay. Number 2, 2r equal to this. From this relation, this is meaningless, okay. And again see that NCR, and that is equal to NC n minus r. Both are same. If we expand this, we get the same value and also we get the same value here. So that's why both are same here. And in this relation, we always write that if n equal to n, so these n equal to, they are the sum of suffix they are equal to n. If we add the suffix, then see r are cancelled, then n equal to n. So this is another procedure. So by this method, we have to write here 10 is equal to 2r plus 4r plus 4, okay. Then 6r, and that is equal to 10 minus 4, that is equal to 6. So r is equal to 1 is your answer. R equal to 1 is your answer. This is the perfect method, okay. Now again, see the question number 9. 2 to the power 2n minus 3n minus 1 is divisible by 9. We have to show this is divisible by 9. Okay, see, this is 2 to the power n minus 3n minus 1, given n is more than 1. 2 can be 2 to the power 2n can be expressed as like 4 to the power n, okay, minus 3n minus 1. So 4 means 1 plus 3 to the power n, 3n minus 1. And expand this expansion by binomial theorem. So that is nc0. So nc1 into 3, nc2 into 3 to the power 2, nc3 3 to the power 3, and so on to ending term be ncn 3 to the power n minus 3n minus 1. See, this is 1. If we split nc1 by factorial, then we get n, so 3n here. So cc nc2 3 square, nc3 3 cube, nc n 3 to the power n minus 3 and minus 1. So 1, 1, 3n, 3n are cancelled out. Taken common, the least degree of this expansion of 3 is 2 here. So we have to take in common 3 to the power 2. Sorry, 3 to the power 2. Okay, 3 to the power 2. So see, n is a positive integer, and given that n always more than 1. So you start from here, n equal to 2. So least value I have in B2 here. So we can take in common 3 to the power 2. Okay, 3 to the power 2. So NC2, NC3, NCn and 3 to the power n minus 2 here. Okay. Okay. So it means it is divisible by 9 and whole this part is a integer. Okay. So it's proof it is divisible by 9. Bye.